We've looked at how to construct the hypotheses to conduct a test for a correlation coefficient. A little bit later, we'll get to how we calculate the p-value for that test. For right now, we want to focus on a given p-value and how we would write our conclusions. So we're in example 4, a researcher finds that a paired data set has a correlation coefficient of 0.8086 and wants to test the claim that a positive association exists between these two data sets. In part A, we want to construct the hypotheses, which we already did in example 1. The null was that rho is equal to 0, and the alternative was that rho is greater than 0. If testing the hypotheses yielded a p-value of 0.0546, and we're using a significance level of 0.1, what decision can we make regarding the null hypothesis? Well, in this case, our p-value is less than or equal to 0.1, which is our significance level. So we would reject the null hypothesis. This means there is sufficient evidence to discredit the null hypothesis. So we conclude, since we discredited the null hypothesis, we conclude the alternative that rho is greater than 0. And that means the claim is supported the two data sets share a significant positive association. Example 5 connects back to example 2, where we had what I'm going to call a more suspicious value for the correlation coefficient. It's not really close to -1, but it's also not really close to 0. It's in this in-between range. So for a case like this in particular, hypothesis testing can be very important to help us draw a better conclusion about the strength of that result. We already determined here that our null hypothesis would be rho is equal to 0, and the alternative would be rho is less than 0. If testing the hypotheses yielded a p-value of 0.2649, and our significance level is 0.05, what decision can we make regarding the null hypothesis? In this case, our p-value is greater than 0.05, which is that significance level, so we fail to reject the null hypothesis. That means there is insufficient evidence to discredit the null hypothesis So we maintain the assumption that the population correlation coefficient rho is equal to 0, meaning the claim is not supported and we'd say the two data sets do not share a significant association. keeping in mind that for this conclusion and all others, that is based off the data that we have available. In example 6, we're looking at the situation we first talked about in example 3, where our null hypothesis was rho is equal to 0, and the alternative was that rho is different than 0 or not equal to 0. If we get a p-value of 0.0015, our p-value is less than or equal to 0.01, so we reject the null hypothesis. That means there is sufficient evidence to discredit the null hypothesis. So we conclude that rho is something different than 0, the population correlation coefficient is not equal to 0, and the claim is supported the two data sets share a significant association.